Welcome to the chemistry class. We are in the chapter Aldehydes and Ketones, session 9. In this session, we will discuss about two important reactions. One is Cannizzaros reaction and the other one is Tischenko reaction. So the aim is to explain Cannizzaros reaction and Tischenko reaction with mechanism. Cannizzaros reaction. This is the reaction that is given only by aldehydes. That is only aldehydes, that too containing no alpha hydrogen, take part in Cannizzaros reaction. So these aldehydes having no alpha hydrogen, when refluxed, that is strongly heated with strong alkali such as concentrated NaOH or concentrated KOH, that is a 50% solution, self-oxidation and self-reduction. That is simultaneous oxidation and reduction of the given aldehyde takes place to give a salt of carboxylic acid and an alcohol is produced. That is, during this reaction 50% of the aldehyde undergo oxidation and the remaining 50% of the aldehyde undergoes reduction. Therefore, equimolar mixture of carboxylic acid and alcohol is produced. So this method of converting an aldehyde having no alpha hydrogen by refluxing with strong solution of either 50% NaOH or KOH so as to bring about the simultaneous oxidation and reduction to give a salt of carboxylic acid and an alcohol is called Cannizzaros reaction. So aldehydes without alpha hydrogen when refluxed with strong solution of 50% either NaOH solution or 50% KOH solution, simultaneous oxidation and reduction of the aldehyde takes place to give a salt of carboxylic acid and an alcohol is called Cannizzaros reaction. Then what are the examples of aldehydes having no alpha hydrogen so that they can undergo Cannizzaros reaction? So the examples of aldehydes which undergo Cannizzaros reaction are 1. Formaldehyde, that is CH2O, benzaldehyde C6H5 CHO, trichloroacetaldehyde CCl3 CHO, or trimethyl acetaldehyde CH3 tris C CHO. So these are the few examples of aldehydes having no alpha hydrogen which can undergo Cannizzaros reaction in the presence of strong alkali. Let us take an example. Formaldehyde, that is CH2O, HCHO. As you can see, it has got only the functional carbon, no alpha carbon at all. So there is no question of this aldehyde having any alpha hydrogen. So formaldehyde is the best well-known example of aldehyde having no alpha hydrogen. So when 2 moles of this, another molecule of formaldehyde, is subjected to strong heating, that is treatment with strong solution of NaOH such as 50% NaOH, during which 1 molecule of an aldehyde will undergo oxidation to give the salt. Here in this case, it is the sodium salt of formic acid. Sodium formate, that is sodium methanoate is formed. So this is the salt of an acid which is the oxidized product of 1 molecule of an aldehyde. Then the other molecule of formaldehyde will undergo reduction to give alcohol, and the alcohol formed by the reduction of formaldehyde is methyl alcohol. So this reaction is Cannizzaros reaction. Then example 2. When we take an example of benzaldehyde C6H5 C-double-bond-OH and another molecule of benzaldehyde, both of which do not contain alpha hydrogen. So when it is subjected to refluxing with strong solution of 50% of NaOH, then say this molecule of benzaldehyde gets oxidized to give sodium benzoate C6H5 COO minus Na plus. That is sodium benzoate, which is the salt of benzaldehyde during the Cannizzaros reaction, which is considered to be the oxidized product. Then what about the reduced product of another molecule of benzaldehyde? So it is another molecule of benzaldehyde which undergoes reduction to give benzyl alcohol, that is C6H5 CH2OH. So one is benzyl alcohol and the other one is sodium benzoate, which are the Cannizzaros products of benzaldehyde. Then example 3. Let us take another aldehyde having no alpha hydrogen such as metachlorobenzaldehyde, means substituted benzaldehyde. Then we get this is the benzaldehyde and this is the metachlorobenzaldehyde, M-chlorobenzaldehyde. What will be the products of this metachlorobenzaldehyde on Cannizzaros reaction? So that one of the products is the salt of the aldehyde, so there will be no change. It's metachlorosodium benzoate becomes the one of the products. and the other one will be the reduced product, which is nothing but the benzyl alcohol, and the substituent in the meta position is chlorine. Therefore, it's called metachlorobenzyl alcohol. So this is the Cannizzaros reaction. So what is the mechanism by which this reaction goes? And further, we can see two molecules of an aldehydes are taking part in the reaction. Hence, it's called intermolecular Cannizzaros reaction. So let us see the mechanism by which this particular reaction takes place. Since the reaction being carried out in the presence of a strong base, it is the OH minus that will first of all attack the carbonyl carbon of the aldehyde, so that the pi electrons of the given aldehyde shifts towards the more electronegative oxygen atom to give an alkoxide ion. So the first step is attacking of OH minus, which acts as a nucleophile on the functional carbon of one aldehyde and generate alkoxide ion. That is, this is the formaldehyde which we have taken as an aldehyde, and it is the OH minus which will attack the functional carbon. Hence, it is acting as a nucleophile. The pi electrons shift towards the more electronegative oxygen atom and thereby result in CH2OH O minus. So this is the alkoxide ion that is formed. And in the next step, this alkoxide ion formed, that is anion formed, acts as a hydride donor, that is transfer of hydrogen with an electron pair. Hydrogen with an electron pair is called hydride, will be transferred to the second molecule of the aldehyde, that is this CH2OH minus, that is this CH2OH O minus. The alkoxide ion, or in other words anion, will transfer a hydride ion to another molecule of aldehyde taken. So therefore, it is this hydrogen with electron pair will get transferred to another molecule of aldehyde, so that this electron pair from the oxygen shift in between two carbon oxygen, resulting in formic acid. In this case, that is, in general, it is a carboxylic acid that will be formed. And as this hydride ion attacks this, the pi electrons shift towards the more electronegative oxygen and give CH3O minus. So it is now methoxide ion that is formed. So therefore, formic acid and methoxide ion becomes the products. And in the third step, as we know, the carboxylate ion being more stable than carboxylic acid itself, there is an exchange of proton from the acid to alkoxide ion to give the stable products. In other words, this hydrogen which is acidic in nature will be transferred to this alkoxide ion oxygen and result in, from these two, it is carboxylate ion. In this case, it is a formate ion. As we know, formate ion is more stable than the corresponding formic acid. So it becomes formate ion, which will combine with Na plus of the sodium to give sodium formate. And meanwhile, this becomes the methyl alcohol CH3OH. Thus, the major reaction involved in this case is the transfer of hydride ion from alkoxide ion to another molecule of formaldehyde is an important step. So this is what is the mechanism by which the reaction goes. Let us take another example, example 2, and discuss the mechanism by which the reaction goes. It can become further clear. So when we take benzaldehyde, which is an example of an aldehyde having no alpha hydrogen. So therefore, when this benzaldehyde is allowed to react with OH minus, as this OH minus will come and attack the functional carbon, pi electrons will shift onto the oxygen atom to give C6H5 CHO minus, and this OH group is attacking here. So this is the first step. Anion is formed. And in the second step, it is this C6H5. As you know, we can write C6H5 as 5, and this is CHOH minus, which is formed in the first step, will transfer one hydrogen with electron pair. That is, this hydrogen with electron pair is transferred. That is called hydride ion transfer. H minus transfer takes place. And this H minus transfer to this will immediately shift the pi electrons towards this, and also this electron pair will come in between two carbon and oxygen. So what will be the now products? This is 5, C6H5. It is C double bond O, OH. So acid is formed, which is the oxidized product. And the other one is C6H5. H is already there and one H minus is attacking this. So it will become C6H5 CH2O minus. And this is the hydrogen which is acidic in nature. and this hydrogen without electron pair, that is called proton, will be transferred to this oxygen, which is already carrying the negative charge. And further, the benzoate ion formed now from benzoic acid is more stable than benzoic acid itself. So thus, it is the benzoate with sodium ion left over in the first step will become sodium benzoate. And after this proton transfer, it becomes benzyl alcohol. So thus, sodium benzoate and benzyl alcohol are the products of Cannizzaros reaction of benzaldehyde. And here the mechanism takes place in 3 steps, and the transfer of hydride ion is considered to be the crucial one.